In general, non-ferrous metals like copper and aluminium are much weaker than ferrous metals. You can prove it with a simple tensile test. Using testing equipment to stretch the metal, the force needed to break it can be measured. The dial shows the amount of force applied. Mild steel has greater tensile strength than the non-ferrous samples. Non-ferrous metals are therefore seldom used in their pure form in components that may be subjected to tensile or shear forces. They have, however, one great advantage over most ferrous metals: an ability to resist corrosion. They don't rust or oxidize easily. These samples of mild steel, copper and aluminium have been put into a heavily corrosive atmosphere which accelerates the normal processes of corrosion. When the samples are removed after a few hours, the non-ferrous metals have corroded slightly. In the case of aluminium, the oxide formed provides a protective coating. But the mild steel is very badly rusted. Copper has several desirable properties. It has good electrical conductivity and is very ductile. In its purest form, copper is produced by the expensive process of electrolysis from a mixture of imported blister copper and scrap metal. This mixture goes through a series of furnaces until it becomes 75% pure. It's then cast into large copper anodes. At this stage, most of the impurities have been removed. The shape of the cast anodes allows the heavy copper slabs to be easily transported for the final purification. After cooling, these anodes are placed in large tanks ready for electrolysis. Separate, pure, thin sheets of copper, which act as cathodes, are placed into the tanks, which contain dilute sulfuric acid and nickel salts. Then a high current with a low voltage is applied. During the next 8 to 10 days, the current is carried from the positive anode to the negative cathode in the form of positively charged copper ions. These are attracted to the cathode, and when the process is finished, the cathode has increased in size and is now virtually 100% pure copper. The finished cathodes are removed, and having an electrical conductivity second only to silver, they're ready to be used in other industries. Some are remelted, and using a process known as continuous casting, formed into long copper billets. Once cut, the finished billets form the basis of many processes requiring a pure form of the metal. If the properties demanded by industry include better tensile strength, then copper must be mixed with other metals, alloyed. Brasses are copper-based alloys in which the major alloying additive is zinc. They're either made from virgin metals or, as in this case, are reclaimed from scrap.